Hi dear students, welcome to my video. So this video I am going to teach about Crout's LU decomposition method. In my previous video I have done Doolittle method, and this video I am going to explain about Crout's LU decomposition method. So the given problem is solve using Crout's LU decomposition method. Given equations are x1 plus x2 plus x3 is equal to 1, 4x1 plus 3x2 minus x3 is equal to 6, and 3x1 plus 5x2 plus 3x3 is equal to 4. The given solution is first, whenever the system of equation is being given, we need to find out the coefficient matrix A. So to find the coefficient matrix A, it is nothing but the coefficients of each unknown variables x1, x2, x3. From the first equation, it is 1, 1, 1, and the second equation, it is 4, 3 minus 1, and the third 3, 5, 3. So that is what the coefficient matrix 1, 1, 1, 4, 3 minus 1, 3, 5, 3. Then the next step is we need to put the coefficient matrix A into LU. That is, L stands for lower triangular matrix and U is for upper triangular matrix. And L is going to be in this form. L is going to be L11 0 0, L21 L22 0, L31 L32 L33. That is, all the diagonal elements in lower triangular matrix will have the values. And here upper triangular, it is Y11 U123 U13 0 U22 U23 0 0 U33. So since A is equal to LU, I am going to multiply these two matrices L and U by ordinary matrix multiplication, taking UII is equal to 1. So UII is equal to, since in the Crout's method, it is very important to denote UI, that is all the diagonal elements, U11, U22, U33. I am going to take it as 1, 1, 1, and then going to multiply each matrix. So if I start multiplying each matrix L and U, so ordinary matrix multiplication, that is first row with the first column, first row with the second column, first row with the third column, like that, second row and third row. So by matrix multiplication, I am arriving the single matrix L11, L11 U12, L11 UN3, L21, L21 UN2 plus L22, L21 UN3 plus L22 U23, L31, L31 U12 plus L32, L31 U13 plus L32 U23 plus L33. So this is the single matrix after multiplying the lower triangular matrix and upper triangular matrix, which is equivalent to the coefficient matrix. Now since we know that both matrices are going to be equal, then their values also must be equal. So that means your L11 is equal to 1 and L1 U12 is equal to 1. L11 U13 is equal to 1. Simultaneously, L21 is equal to 4, and this equation is equal to 3, and L21 U13 plus L22 U23 is minus 1, and L31 is 3, and this L31 U12 plus L32 is equal to 5. The last equation, L31 U13 plus L32 U23 plus L33 is equal to 3. So by doing so and equating that, we will be able to solve the values of all the LIs and UIs. So by doing that, I am getting the values as like this. So L11 is 1, L11 U12 is equal to 1. So I substitute for L1 as 1, I am getting U12 is equal to 1. Here L21 is 4, I am substituting in this equation, I am getting the value for L22 is minus 1. And L31 is equal to 3. I am substituting this given equation. So here I am getting it is L32 is equal to 2. Similarly, L11 U13 is equal to 1. And then U13 is equal to 1. So you are getting U13 is equal to 1. And again this equation L21 U13 plus L22 U23 is equal to minus 1. We know the value of L21. We also know the value of U13. And L22 is also equal to minus 1. So it is easy to find out what is U23. So U23 is going to 5. The same way, I am also substituting here and arriving the value of L33 is equal to minus 10. So we have done for all the values that I am going to put in the matrix in L and U. So I will be getting that the lower matrix L 1 0 0, 4 minus 1 0, 3 2 minus 10, and u is going to be 1 1 1 0 1 5 0 0 1. All these li's values, ui values I am substituting in the matrix, and I am getting the value for the lower triangular matrix and as well as for the upper triangular matrix. Then, having determined the matrices L and U, then the system of equation Ax is equal to B becomes Lux is equal to B. That is, A I am replacing by Lu, so I am getting the equation as Lux is equal to B. That is going to be the equation number 1. Next step is we write this equation as a system of equation as Ux is equal to Z and Lz is equal to B. By going for such kind of substitution, I am able to find out what is Z, and once I know Z, then I can go and substitute in equation 2 Ux is equal to Z, and we know U and we also found out Z, then it is easy to find out what is X. So here I have to take Z as a column matrix, Z1, Z2, Z3, and X is X1, X2, X3. The unknowns Z1, Z2, Z3 are determined by forward substitution, and the unknown X1, X2, X3 are determined by backward substitutions. So from equation 3, what is our equation 3? Equation 3 is Lz is equal to B. Z is this form, Z1, Z2, Z3. Now I need to find out what is the value of Z1, Z2, Z3. And already we know L. Let us go and substitute. So by substituting, I will be getting that as L is equal to 1 0 0, and Z is Z1, Z2, Z3, and the B is going to be 1 6 4. That is, we will get from the equations right hand side. So when I started equating that, so Z1 is equal to 1, and then 4 Z1 minus Z2 is equal to 6. So when I start substituting, I will be getting Z2 is equal to minus 2. Similarly, 3 Z1 plus 2 Z2 minus 10 Z3 is equal to 4. So we know Z1 Z2, so we can substitute for Z3, and Z3 is going to be minus half. Then when we come back to the second equation, Ux is equal to Z, Ux is equal to Z, U is going to be 1 1 1 0 1 5 0 0 1, X1, X2, X3 we need to find out, and from the previous one we know the value of Z1, Z2, Z3, so that is your Z matrix. So now again ordinary multiplication, we will be getting that x1 plus x2 plus x3 is equal to 1, x2 plus 5x3 is minus 2, x3 is minus half. So this is what backward substitution, we know the value of the last one, and this value we need to put in the previous equations. So we'll be getting the value of x2. Once we know x2 and x3, we go for the first equation and we are finding the value of x1. So since x3 is minus half, I am substituting the second equation. I am arriving that x2 is equal to half. And then this value is x2 and x3. I am substituting the first equation and I am arriving the value as x1 is equal to 1. Now we found all the values of x1, x2 and x3. So the final solution is x1 is 1, x2 is half and x3 is minus half. This is the solution of the above system of equations by Crout's LU decomposition method. Thanks for watching. Bye. See you in the next video.